Hi guys, welcome to part 6 of EDK2 PPIs. So let's try to understand what we have learned from part 1 to 5. Okay, so now part 1 talks about to decide the order of execution of a particular PIM module, whether that driver should be dispatched or not. In the part 2, we discussed about how to trigger the notify events between the two PIM modules. The third part is so to share some fixed data, it might be some variable data or it might be a pointer, can be shared between the two PI modules. And the part 5 is to share the interfaces between the different PI modules. Okay, let's try to understand all the 5 parts in detail. Okay, so the first one is to decide the order of execution, right? Whether it should be dispatched or not in the paint. Okay, so now assume this is where our BIOS started and this is the security phase. Okay, and this is our PI phase, and then this is our Dixie and BDS and all. Okay, so now this is a security phase, this is a PI phase, Dixie phase onwards. Okay, so now in this PI phase, right? So if I expand this, okay, so I will draw another line. Okay, so here I will call this as PM started, PM phase started, okay, and here PM phase ended, okay. So within this phase, the multiple PI drivers will get dispatched, right? So now let's say from here to here, driver 1, driver 2, driver 3, 4, 5, 6, 7, 8, 9, 10. Okay, assume there are 10 PI drivers. Okay, so now let's add few names. 1, 2, 3, 4, 5, 6, 7. Okay. So now the drivers will get dispatched one after the other, right? So now assume there is a criteria. So we are talking about this point one to decide whether the driver should be dispatched or not. Okay. So now assume let's consider this driver 4 as an example. Okay. So now assume so this driver 4 is dependent on some other module. Okay, so without that module get executed, it should not get called at all. Okay, so meaning assume this driver 4 is there under the firmware volume. Okay, but this should not be dispatched until this 6 execution is happened. Meaning, so once this execution of this 6th module is completed, so then only this driver 4 can be executed. Okay, so how we are going to do this? So we are going to do with the help of depex in the INF file. Okay, so what the depex is going to do? So it will add the dependencies before it started dispatching that particular driver. Okay, so in this case, the driver 4 is dependent on the driver 6. Okay, so now let's go back to this one. So second one is uh, PPI notify events. Okay, so now here assume we have suppose that this driver 3, right? So this driver 3 will perform certain tasks. Suppose say memory initialization, not memory, maybe um, some XYZ task it is going to perform. Okay, but along with that, it has to perform some J some K task, but this K task can be performed only after some other functionality got executed. So maybe let's take this memory init or memconfig done or memory init is going to complete, right? So only memory once this memory init is going to complete, this K task should be executed. Okay. So now this k task is still be a part of this driver 3. Okay, so when this driver getting executed, it will perform X, Y, Z task. Okay, but this k task cannot be performed because it has a dependencies on the memory init module. Okay, so once the memory is up, then only this k task can be executed. Okay, so now assume this driver 5 is a memory init. Okay, so mem init complete will be done by this driver 5. Okay, so now, so this k can be complete, k should be executed only after this memory init is going to get completed. Okay, so in that case, how this driver 3 can decide when this memory init is going to completed or not, right? So the first thing what this driver 3 is going to do is, so he is going to trigger the notify events. Okay, so this driver 3 is going to trigger the notify event for this k task. Okay, and then that will be stored in the PA services. Okay, so now when this driver 5 get called and when it is getting executed, it will install the PPI. Okay, install PPI of minute complete. Okay, so now as soon as this PPI getting installed, it will go and look for the PA services whether has anyone registered this GUID for a notify events. Okay, so now in this case, the module 3 has triggered the notify event of this GUID, and so since it is installed that GUID notify events, right? So now as soon as this PPI getting installed, so before this driver 6 or before this next task getting executed, right? So this key notify event will get called, meaning, so assume this driver 5 is going to perform some task, right? Suppose a task A, task B, task C, D, and E. Okay. So now this PPI init is going to complete, will be PPI init complete will be installed somewhere around step C. Okay. So now before this step D getting executed, this K task will come into picture and the K will be executed from here. Okay. S- So So the third part is about share some data between the PI modules. Okay, so that data can be a pointer or some variables or the memory location address. Okay, so let me do this and do. Okay, so now assume this is, suppose say, maybe graphics module 1. Okay, so this is done at the premium. Okay, so now here per minute will get complete, and here GFX module 2. Okay, so now if any data to be shared from the pre-mem to post-mem, right? How we can do? So there are multiple ways of sharing the data. We can share with the dynamic PCDs or the hops or the PA services, right? So in this in this case, we are talking about the PA services, which are PPIs. Okay, so now in this in this one, right? So what this driver 3 is going to do is, so it is going to install a PPI. Okay, so that PPI will be pointing to either a variable or a memory location which you have done for the allocate pool of memory, right? So either it can be point to some memory location or some variable. Okay, so now this driver 2, what he is going to do is, so he is going to locate the PPI and then he can able to retrieve the data. Okay, so in this case, it can be assume the variable data we are talking about, right? So assume this is a variable data. So this variable data can be retrieved here in this driver 7. Okay, so assume it is assume this driver 3 is going to allocate some temporary memory, right? So now the pointer of this base address of this temporary memory, right? So assume it is going to store in this PPI, right? So now to retrieve, to locate here, right? So what it is going to do? So the same pointer will be can be retrieved from here. Okay, so now assume this is pointing to a memory location, right? Now this is a pre-mem, so we are running under the cache, right? So now in case of post-mem, this will be migrated to a permanent memory. Okay, so now this address may not be exactly same in the post-mem, right? But the PI services is going to modify this address which is stored in that PPI itself. Meaning, so assume in our pre-mem, this is pointing to some memory location FE0000 E4 something. Okay, so now after this memory unit is going to complete, so the same data is migrated to the permanent memory, right? So that permanent memory can be pointing to suppose say 4E0000 some E4 something, right? So now this data is migrated to this permanent memory. So when this PI services is going to locate the PPI and when it is retrieving this data, right? So it will give the updated pointer so that this module will get the same exact data what it has reserved in the premium. Okay, so this is the best use case. So this feature is not available in the hops or the PCDs. So this pointer fixup can be done in the PI services only, as per I know. Okay, so now let's talk about this part 4 and part 5, right? So let me do this undo. Okay, so now assume this is a graphics module, right? So to bring up the display or to bring up the graphics device, right? It is known to this driver 3 only and or driver 7. Okay, so now if someone wants to get the information about the display, right? Suppose say if someone wants to get the information about the display or the graphics config space uh, or the graphics memory or the or maybe the VGA space or whatever the information, right? Which is known to this graphics module only. Okay, so now assume this driver 6 or driver 7 or driver 8, right? So if it wants to know some certain information from this driver 3, right? So that information, either that can be a information or it might be some certain execution. It depends based on the use case. Let's talk about both. Okay. So now, if this driver wants to if this driver wants to get some data from this driver, right? So this can expose the interface. This driver, right? This driver 3 can expose the interface. Okay, and this driver 7 or driver 8 can locate that interface and then it can call that interface to get the required data. Okay, or for example, bringing up of the display, right? So the required functionalities can be added here, but this data can be called by any other module, either this 4 or 5, 6, 7, 8, whoever they want, right? So they can simply locate the PPI and they can call the interface and they can get the job done. Okay, so now we have multiple examples in the EDK2. So a few of the examples I have already demonstrated in the part 4 and part 5. Okay, so this is the ending of the PPIs. So in the next video, we are going to talk about the hops to share the data between the PIM to PIM within the PI driver and PI to Dixie as well. Okay, so that's it for today. Thank you.